All right, in this example, I'm going to show you guys how to identify characteristics of a sine function given the actual equation of the sine function. So I'm given a function here, y is equal to the negative of 2 over 5 sine x plus 15 plus 4. Okay, so the first thing I want to identify is what is the amplitude. Now, if you're unsure how to find the characteristics, I always try to always compare it to the actual general function. So y is equal to a times the sine of square brackets b x minus c square brackets plus the d value. Now a, b, c, and d each relate to one of the characteristics. Now when you're looking at the amplitude is quite easy. If you want to find the amplitude of a function, you always look at the a value. So looking at the a value here, we have negative 2 over 5. Now amplitude, I want you to always understand that that is a distance value. So distance is always positive. So to find amplitude, you're taking the absolute value of a. Okay, so in this situation here, we have the absolute value of a, which is negative 2 over 5. When you take the absolute value of a negative number, you always get a positive value. So there is my amplitude. My amplitude is, it is 2 over 5. Okay, so it's going to be a very short amplitude if you graph it. The next thing you want to identify, since the amplitude is done, is the period. Now, when you're looking at a period, the first thing you want to look at is what type of function are we working with? We are working with a sine function here. So to do the period, you're going to use a formula. There's actually two possible formulas, and it all depends on what units you're in. Now, we are working with degrees here. A good clue of that is because the 15 is in 15 degrees, right? So the period formula you want to work with here is 360 degrees divided by the b value. And since period is once again a positive value, so it's a distance again, it's the distance at which this graph is repeating itself, you are actually dividing by the absolute value of b, so we always get a positive value. So 360 degrees divided by the b value. Now if we look at our function here, what is our b value? Now we do actually have a b value. The b value sits in front of the x minus c. So it's part of the argument. So if I put square brackets around the x plus 15, my b value is actually 1. Okay, so let's use a different color here. This is exactly 1. Okay, so my b value is 1. So we have the absolute value of 1, which is just 1. So my period for this graph is 360 degrees. So every 360 degrees, the graph starts to repeat itself. The next thing I want to identify is the phase shift. Now remember, phase shift is the left and right movement of a graph. Okay, so it's a horizontal translation. To look at the horizontal translation, we are looking at the c value. Okay, so your c value is always attached to your x value. Now, if I'm looking at this general function, I'm comparing it to the function given. My c value is actually right after the x. So here is my c value. Now notice the general equation is a negative. So therefore my c value is actually negative 15 degrees. It's just like when you work with quadratics, you always want to switch that sign there. So my c is negative 15. So I say that my phase shift is 15 degrees to the left. Okay, and the reason why it's left, it's because it's a negative value. So 15 degrees to the left is my phase shift. Next thing I want to identify is the horizontal midline. Okay, so my midline axis, remember, that's the line that goes right through the middle of my graph. To find the midline, it's quite easy. You just look at one parameter, and the parameter that gives you the midline is the d. Okay, so midline is equal to the d value. My d value for my function is the plus 4. So what's happening here is that I moved up 4 units. So as a result, my midline is right along 4. The last thing I want to identify here is the range. Now, to identify the range, you need to know two things here. You need to know what is the max and what is the min. Okay, so looking at this graph here, since I know that my midline is across 4, okay, so it's been translated 4 units up, my amplitude is quite small, it's 2 over 5, so my graph will look something like this. Very rough sketch, but that's the idea of this graph. Holy, okay, there we go. All right, so here's my graph. I need to find the range, so I need to find out what is the maximum point and what is the minimum. That will tell me what my range is. To find the maximum, you take your d value, which is your midline, Okay, take your d value and you add your amplitude. Okay, so let's add our amplitude to our d value. So my d value was 4, my amplitude was 2 over 5. So therefore, I get 22 over 5 as my maximum value. My minimum value is done very similarly, but this time I have to take my d value and subtract my amplitude. That will give you this low point down here. So my d value is 4, and I'm subtracting my amplitude, 2 over 5. And if I had done this correctly here, I get 18 over 5 as an answer here. Okay, so to conclude this question here, I'm going to state that my range is defined as follows. So my range, I'm only talking about my y values here. Y has to be greater than or equal to 18 over 5, which remember is my minimum, but it has to be less than or equal to 22 over 5 because this is my maximum point. Okay, and that is how you do that question.